Hello guys, uh, our video today is on Bessel's equation. We have x raised power 2, y prime prime plus xy prime plus x square minus v square y. The first thing to do is to open a bracket. Let's open these brackets. We have y prime prime plus xy prime plus x square y minus v square y equals to 0. That's the first step to do. Now the next step is to write out our trial series. Remember, for Frobenius equation, it's still the same thing as we are still using the same approach, the same formula as Bessel's equation. Now, for Frobenius, y equals to x raised power c a naught plus a1x plus a2 x squared plus a3 x raised power 3 plus we have ar x raised power r. This is our Frobenius equation formula. Now, the first step is to, because if you can see, we have three type of y. Normal y, this is normal y prime, y prime prime. So we have three type of y. We are going to obtain those three type of y. Now, to get my y, I will use this x raised power c to open this bracket, which we're going to have a naught x raised power c plus a1 x raised power c plus 1 plus a2 x raised power c plus 2. Let's keep a3. So let's go to ar. We have ar x raised power c plus r. That is our y. To get y prime, we differentiate y. So y prime equals to a naught c x raised power c minus 1. Remember, differentiation. We are differentiating it. Plus a1 c plus 1 x raised power c minus 1 from it plus a2 c plus 2 x raised power c plus 1 plus ar c plus r x raised power c plus r minus 1. That is y prime. Let's get y prime prime. Differentiate all this again to give us y prime prime. We have a naught c minus 1 x raised power c minus 2 plus a1 c plus 1 c x raised power c minus 1 plus a2 c plus 2 c plus 1 x raised power c plus ar c plus r c plus r minus 1 x raised power c plus r minus 2. This is our y prime prime. That is the first method. Now the second method is to substitute our differential equation into y prime prime, substitute the trial series. This is our trial series. We have to substitute it into our differential equation. Now we can see that if we are to put y for here, y prime into here, y prime prime into here, we are going to have a long equation. So we are going to separate them, taking them one by one. The first one is x squared y prime prime, which means that we are multiplying y prime prime by x squared. This x squared that is here, it will affect all the x's that is inside y prime prime. So this will be a naught c minus 1 x raised power c. You know, this is minus 1, then we have minus 2, then we have x raised power 2 outside. That will be minus 2 plus 2. It will cancel that one. So the next one will be a1 c plus 1 c x raised power c plus 1. The next one is going to be a2 c plus 2 c plus 1 x raised power c plus 1 c plus 2. We are adding to the power of x's plus ar c plus r c plus r minus 1 x raised power c plus r. The 2 here we cancel, we eliminate that 2. That's for the first one. The second one, which is xy prime, xy prime means that we are multiplying y prime by x. In that case, every power of x's that we have here, we are adding 1 to it because we have x raised power 1 here. So it will now be a naught c c. If you add 1 to it, it remains only c plus a1 c plus 1 x raised power c plus 1 plus a2 c plus 2 x raised power c plus 2 plus ar c plus r x raised power c plus r. If you add 1 to 1, it will emulate that one. Now the third one is x squared y. We have y, which is ordinary y. We are multiplying it by x squared. The x squared that is there, the 2 will affect all the x's that we have in y. So which we have a naught, we're going to have c plus 2 plus a1, this one will be c plus 3 plus a2 c plus 4 plus ar c plus r plus 2. The last one is minus v squared y. We are multiplying our y by minus v squared. So this will give us a minus a naught x raised power c plus, that will be minus a1 x raised power minus a1 v squared x raised power c plus 1 minus a2 v squared x raised power c plus 2 minus ar v squared x raised power c plus r. We notice that there is nothing changed from that power of x. Nothing changed because this we're going to have v squared here, then x raised power c. We don't have any changes in x's that we have because we have v squared, so we cannot add to the power of this. So this is the first method. That is the second method, rather, the second step we're going to use. Now, the third step now is going to be, if you check what we have here, from the first one, which is y prime prime, this is our first y prime prime. From the first y, which is y prime prime, that is where you're going to pick the least power of x. The least power of x. Now this is our least power of x, or you say the first x that you see in the first y prime prime. So you now pick the coefficient. So in that case, we are going to say we are adding the coefficient of x raised power c. Now, anywhere you see x raised power c, we are factorizing out the coefficients. We are taking out the coefficient. This is x raised power c. This is the coefficient. Write it out. A naught c minus 1. That is the first coefficient. If you check to the second equation, we have a naught c only plus a naught c. If you check the third one, we don't have anything that's having x raised power c. So you're going to skip that one. So let's go to the last one. We have this. So which is minus a naught v squared equals to 0. All equals to 0. Now we see that we have something in common. A naught is common. So let's factorize a naught. We're going to have c minus 1 plus c minus v squared equals to 0. We now say where a naught cannot equal to 0. A naught cannot equal to 0. Just remove a naught from it. It's going to remain c minus 1 plus c minus v squared all equals to 0. From here to here, we still have another thing in common, which is c. Let's factorize the c out. So if I factorize the c out, we're going to have c minus 1, then it means plus 1 there, minus v squared equals to 0. Which is, this cancel this, we're going to have c minus v squared equals to 0. C squared equals to v squared. take this minus v square to the other side. We have v square. Then divide both sides, square root both side, which is going to be c equals to plus or minus square root of v square. These two cancel too. Now I have c equals to plus or minus v, which means that the first c equals to v and the second c equals to minus v. Those are the two c we are going to obtain. Let's move on. Now, the next thing now, since we obtain the power of c, let's obtain the power of ar. Let's go to ar. Let's find ar. Now, if you see here, we have x raised power c plus r, x raised power c plus r, x raised power c plus r. But here, we have x raised power c plus r plus 2. We are going to change this c plus r plus 2 to equal to c plus r. We have c plus r plus 2. And I need c plus r. That's what I need. I need to remove our 2. I need to remove the 2. So I will introduce minus 2 into this equation so that this can cancel this. But we can't just introduce minus 2. We have to find a means whereby the minus 2 will come inside to the equation. So we now say let r equals to r minus 2. You know, it's positive 2. The r we are going to introduce will be r minus 2. If you have c plus r minus 1, you say let r equals to r plus 1. Because by the time you add minus 1 plus 1, it will be 0. Or if you have plus 1 here, the r you're going to do it will be minus r. So that's how you're going to do it. Now, so from here, we now say let r equals to r minus 2. So if r is r minus 2, anywhere you see r in this equation alone, in this expression that we have alone, that is where you're going to put r minus 2. Note that this is already in what we need. It's already in what we need. It's already the c plus r that we need. It's only this one that is in c plus r plus 2. So this is the only one we are going to convert. So now, if I convert it, it will be ar minus 2. So you know there is r here as a subscript. So it will be r minus 2, then x raised power c plus r. So you now see that converted everything to c plus r. So we now say that the next thing now is coefficient of x raised power c plus r. So we look for the coefficient of x raised power c plus r. From the first one, we have ar c plus r minus 1 from the first equation. From the second one, we have plus ar c plus r. From the third equation, which is ar minus 2, that's only the coefficients that we have. Now the coefficient for the fourth one is minus ar v square all equals to 0. Let's take this one to the other side. We're going to have ar. Now let's take this one to the other side. Then let's factorize ar out. So if we factorize ar, it's going to remain c plus r minus 1 plus c plus r minus v square equals to minus ar minus 2. Because we carry this one to the other side, so now we factorize ar out. Now we can also see that from here to here, we still have something in common, which is ar. C plus r is still common. So if we factorize c plus r, it's going to remain c plus r minus 1 here. Then the remaining one will be plus 1. Remember that c plus r is common. When you take out c plus r, it's going to remain this and it's going to remain 1 here. So we have minus v square equals to minus ar minus 2. which is going to be c plus r, because this one and this one will eliminate each other, minus v square equals to minus ar minus 2. So we're going to have ar to equals to c plus r square minus v square equals to minus ar minus 2. Divide both sides by c plus r square minus v square. Divide both sides by c plus r square minus v square. We're going to have only a out here equal to minus ar minus 2 over c plus r square minus v square, which we can rewrite. In order to cancel this minus in front, we can rewrite it as ar minus 2 over v square minus c plus r square. We can rewrite it as this. Now let's continue. The next part is to find our R in terms of C. Let's find our R in terms of C. Remember, we obtained two values of C, which is positive V and minus V. But before we insert this one into it, let's find this AR in terms of C. Let's find it first. So we now have AR equals to, now from this equation that we have, we can see that A1 equals to 0, A1 equals to A3 equals to A5 equals to A7, all equals to 0. We cannot have A1, we can't have A3, we can't have A5 and A7. All the odd number will be 0. Why? When you go back to this equation that we have here, the second step that we took, that we have A1, C plus, I forgot it, but when you go there, you see that the next, the first one is under x squared y prime prime. The first one is x raised power c minus 1. The second one, the first one is x raised power c. The first x that you're going to see here is x raised power c. The second n is x raised power c plus 1. The second x is x raised power c plus 1. When you take out all the coefficients of x raised power c plus 1 in all the equation that we wrote out in the first place that I claimed here, we are going to see that everything is going to have A1, A1, A1. Everything is going to be in form of A1, A1, A1. Now, when you have, in the case where you have only one A, like A1, 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 only one A appear or two, that A will be equal to 0. That is why we are able to obtain our C. Because A naught, A naught, A naught, that is what we have all through. So we now say A naught cannot be 0, so we eliminate A naught. Same thing, if you check the power of x raised power c, go back to check the power of x raised power c, you are going to see all the A that you have there is A1. So A1, we are going to eliminate A1. So A1 is going to be 0 because you don't have any other A there. If you have like A1, 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 and A2, you will be able to obtain the value for A1. But since it's A1 all through, you cannot get the value of A1. So A1 equals to 0. And when A1 equals to 0, A3 will be 0, A5 will be 0, so also A7. So let's continue now. So we are going to find the value of A2. We are going to start from A2. We can start from 0 because we have x raised power r minus 2. So if I say r equals to 0, to be minus 2, and it's not making sense. So we can start from r equals to 2, r equals to 0. So we're going to start from when r equals to 2. So if I put 2 into this equation here, so you're going to have A2 equal to, that will be minus, no, we've eliminated the minus, so that 2 minus 2, that's 0. Then we have we are going to have v squared minus c plus 2 squared. This is what you're going to have when you have a2. When r equals to 4, we cannot get a3, so we go to a4. When r equals to 4, so if I put 4 here, we're going to have a4 equal to 4 minus 2. We're going to have 2. That will be a2 over v squared minus c plus 4. So the next one, when r equals to 6, we're going to have a6 equal to a4 over v squared minus c plus 4. C plus 6 squared. This is what we're going to have. Then we know that the value of a naught equals to this. This is the value of a naught, a2. So let's put in the value of a2, because we are going to change everything to be in form of a naught. So now it will now be, if I put this, this is the a2, this is the answer here. So let's put this one to here. So we are going to have a naught over v squared minus c plus 2 square, v squared minus c plus 4 square. This is what we are going to have. A naught. Now when you do this, this is a4. What is the value of a4? This is what we get for value of a4 in terms of a naught. So you're going to have a naught all over v squared minus c plus 2 square, v squared minus c plus 4 square, v squared minus c plus 6 square. So this is what we're going to have. This is when you find it in terms of c. Now let's go that when c equals to v. When c equals to v, what are we going to get? Since we've obtained this, so let's just pick it one by one. A2 now. So we start from a2. So a2 is what? A naught over v squared minus c plus 2 square. Right? Now our c equals to v. So you're going to put the v here. So that will be v plus 2. V plus 2. Now we can solve this. If you remember, there is something called difference between two squared, which is x squared minus, if you have x squared minus y squared. This is the difference means negative in mathematics. So now it means minus. Difference between two square means that minus between two square. So this is how you're going to solve it. You pick the first x minus y, the second x plus y. This is how you solve it. Now if I want to solve this one, so it's going to be, I pick v minus v plus 2. So you pick 1. Then the other one, pick v again. Now it will now be plus v plus 2. So which we are, if you open the bracket, so you're going to have v minus 2, v plus 2. So which we, this cancel this, you have minus 2, open bracket, 2v plus 2. We have 2v plus 2. Now you can see that there is something in common here, which is 2. So if I factorize the 2, it will now be 2 raised to power 2. If I take out the 2 here, I multiply it, that will be 4. But you're going to write it in terms of this, that will be 2 raised to power 2. Then it's going to be v plus 1. So which means that if I solve this, we're going to arrive at this answer. So which will be minus, the minus now will now go up. We have minus a naught over 2 square v plus 1. So this is the answer that we're going to obtain when we solve this. I hope you write it. We still be using it. Now when we have a4 now, what is the answer for a4? This is a4. We have a2 over v squared minus c plus 4. And our phi is what? Positive v. So we change it to v. So if I solve this again, that will be v minus v plus 4 And again, we have v plus 4. So which is going to be v minus 4, v plus 4. This is v. This cancel this. We have minus 4 outside. Then we have 2v plus 4. 2v plus 4. 3 is common. When you take out the 2, multiply by 4, that's 8. We can write it as 2 raised to power 3. That will be minus 2 raised to power 3. Then it remains v plus 2. So it shows that if I solve this, I'm going to arrive at this. So it will now be minus a2 over 2 raised to power 3. Remember, it's the minus that goes up to this. So we have v plus 2. Now let's change it to a0 because we are finding it in terms of a0. Let's change this answer and let's convert it to a0 now. So if I convert it to a0, what is a2? This is a2, and this is a value that we obtain for a2. Now when this minus everything here come into here, the minus will eliminate each other. So it's going to be a0 over 2 square v plus 1 multiplied by 2 raised to power 3 v plus 2, which we are going to write as a0 over this multiplied by this. We have 2 raised to power 5, right? We have 2 raised to power 5. Now, but we will not write it as 2 raised to power 5. We are going to write it as 2 raised to power 4 times 2. You know, 2 raised to power 4 times 2. In this it says is 5. It's 2 raised to power 5. So this is how we are going to write it. We have 2 raised to power 4 multiplied by 2. Open brackets. Now this will be v plus 1. Then we have v plus 2. So this is the answer for A4. Now for A6, we have a raised to A6 now. It will now be A4 over v square minus v plus 6 square. So if I do this, I will have minus a4 over, if I solve this the same way we are solving it, we are going to have minus 6 in bracket of 3v plus 2v plus 6. When you solve it the same way we are solving the first, second one, we are going to arrive at this. Then we take out this, we have minus 6 times 2. Then v plus 3. This is what we are going to have. Now remember, we are taking it in form of 2 raised power, 2 raised power, 2 raised power. So we are going to find means of, this one will be minus 12. So which is 4 times 3. 12 is 4 times 3. So we can write this as 2 raised power 2 multiplied by 3. Multiply by 3, then we have 2v plus 6. 2v plus 6. Now, what is a4? When you bring in a4 into this equation, it's going to be minus a0 over this 4 here. We multiply 2 raised power 2 here. We're going to have 2 raised power 6. This 2 here, we multiply the 3 here, which is 6. 6 is the same thing as 3 factorial. So this means that here also, let's change it to 2 factorial. 2 factorial is the same thing as 2. That's 2 times 1. Now this 2 multiplied by 3, we have 6. That's 3 factorial. Then we have v plus 1, v plus 2, v plus 3. So now this is what we have. When r equals to 6, our a6, we have this. So the next thing is to write it back to our equation. We're going to put it back to the equation. So if you put this back to the equation is y equals to x raised power c, open brackets, a0. Remember, there is no a1, so we don't need to write down a1. So we have a2 x squared plus a4 x raised power 4 plus a6 x raised power 6. Y equals to x raised power v now. You know, when we have this one is when c equals to v. So you now put that v there. Open bracket a naught. A2, what is A2? Minus a naught x square over 2 square v plus 1. The next one is A4. What is A4? A4 equals to a naught x raised power 4 over 2 raised power 4, 2 factorial, v plus 1, v plus 2, minus, you write this one, you write it there. So let's factorize a naught out. We're going to have a naught x raised power v 1 minus x square over 2 square v plus 1 plus x raised power 4 over 2 raised power 4, 2 factorial, v plus 1, v plus 2, minus dash dash dash. You write this same thing there. Now this is our answer when we have v to be xc to be v. Now let's move into when c equals to minus v now. When c equals to minus v. So if c equals to minus v, so we have the formula to be ar equals to a naught over v square minus c plus 2 plus r square, no, plus 2 square, minus c plus 2 square. Now, sorry, let's start from A2. You know, A2 now, this is what we have for A2. So we write it out. Now, when c equals to minus v, we are going to have a naught over v square minus 2 minus v. You know, it's going to be minus v plus 2. So carry these 2 to the front, then take the v to the back. So we have this. Now let's solve this one the same way we did for that one. Pick v minus 2 minus v, v plus 2 minus v. So if you open the bracket, we're going to have v minus 2 plus v, v plus 2 minus v. This will be 2v minus 2. This one cancel this one, we have 2. So we're going to have 2 is common, that's v minus 1, 2 raised power 2. This is what we're going to have. So it's going to be a naught over 2 square v minus 1. That's what we have. Now A4 equals to A2 over v square minus, it's now 4 minus v. It will be 4 minus v. When you solve it the same way we did for that, we are going to arrive at A2 over 2 raised power 3. Then we have v minus 2. When you solve it, now let's put in this one. Let's put in it here. It's going to be a naught over, you know, this 2 that is coming, 2 raised power 2. That is coming to this. We have 2 raised power 2 times 2 raised power 3, which is 2 raised power 5. But we now write it as 2 raised power 5. We're going to write it as 2 raised power 4 times 2. So that will be 2 raised power 4 multiplied by 2. Then we have v minus 1, v minus 2. Now the same way, A6 is going to equal to, our A6 is A4 over v square minus 6 minus v square. When you solve this, you're going to have A4 over, remember the same way we did for that one, we have v minus C minus V, V minus plus C minus V. So this is V minus 6 plus V plus 6 minus V. This one cancel this, we have 6 outside. Then we have 2V minus. Here and here we have 3 in common. So if I take out the 2 times 6 that is outside, it's going to make V minus 3. So you're going to write it as 2 raised power 2 times 3, V minus 3. So which means that here we're going to have 2 raised power 2 times 3, V minus 3. Now when you now put in the value, this is A4. What we have for A4, this is what you have for A4. When you put in the value of A4 into this equation, we are going to have A naught over this raised power 4, we multiply this as 2 raised power 6. 2 times 3, we have 6. But we're going to write it as 3 factorial. Then we have V minus 1, V minus 2, V minus 3. Now this is our answer when V equals to, when C equals to minus V. That is what we are going to obtain. Now the next thing now is to write it in form of this. So we have y equals to x raised power c over a naught plus a2 x squared plus a4 x raised power 4 plus a6 x raised power 6. Y equals to x raised power minus v now. You know, so this is minus v now. So we have a naught plus, what is a2? We have a naught x squared over 2 raised power 2 v minus 1 plus, this one is a naught x raised power 4 all over 2 raised power 4 2 factorial v minus 1 v minus 2 plus the third one, you write that one. Now we have a naught equals, a naught is common, let's factorize a naught minus v. It may 1 x squared over 2 squared v minus 1 plus x raised power 4 over 2 raised power 4 2 factorial v minus 1 v minus 2 plus the last one, you write it out. Now the final answer is going to be in form of y equals to u plus v. That's the final answer. So which is that the first one is going to be our u, y equals to a naught x raised power v 1 minus x squared over 2 squared v plus 1 plus x squared over 2 raised power 4 2 factorial v plus 1 v plus 2 minus dash plus x raised power v now minus v now in bracket of 1 a naught x raised power minus v. So we have 1 plus x squared over 2 squared v minus 1 plus x raised power 4 over 2 raised power 4 2 factorial v minus 1 v minus 2 plus the last one. Now what we're going to see is that we are going to change, you know, this is a naught. Let's differentiate it by changing this one to capital A, by changing this one to capital B. This is going to be our final answer. This is our final answer.